I appreciate your commitment. I also appreciate your trust that you can learn well from us. We're making every effort to ensure that we take away the fear most students who are learning calculus for the first time get involved in, hence all this extra effort. So I appreciate you, and I encourage you to continue to visit the channel to learn more and then interact with us in the comment section. Here we're going to, the plan is to dish out practice problems that take care of most of the topics we have studied in the channel, and then we wish to also continue to put in new topics, and then generate more problems and get you engaged the more. So I encourage you to study the problems, do them by yourselves. Where you find it challenging, like I always say and you have always done, you drop your challenge on the comment section. We will deal with that so that you learn better. Alright, so we begin with this. In no order the problems I'm going to drop will come. They're just randomly picked to help us review each of the topics we have learned. Okay, first, so I target practice problems. Okay. Practice problems. 1. Let y be ln of x raised to power 3 sine of x this way divided by 2x plus 1. The problem is find the derivative of y with respect to x. Number 2. Evaluate or compute, better still, compute dy by dx if y is the function x to the 3 sine x to the 3 sine inverse of 6x squared. So this is as a little hint, you can look at it, not as you can look at, you see that this is the product of two differentiable functions of x. So you have to apply the product rule to deal with the derivative. Here this is a differentiation of inverse trigonometric function. So with these hints, I'm sure to deal with this is not difficult anymore. Number 3 says assume that the limit as x tends to 2, f of x is 5. So is it possible? Is it possible for f of 3, f of 2 for instance, f of 2 to be 3 for example, so is it possible for us to have this situation? And then he says you should explain your answer. That means if you say it is not possible, you tell us why it's not possible. If it is possible, you also explain the reason it is possible. Okay. Number 4 says what does it mean to say that limit as x tends to 1 from the negative of f of x is 3, and the limit as x tends to 1 from positive, this function is, for instance, 7. So what does this mean? Number 5 says evaluate limit as x tends to 0 of the square root of x plus 4 minus 2 divided by x. 6 says determine limit as x tends to minus 3 from positive of x plus 2 divided by x plus 3. And then this one says we should find the limit as x tends to 2 from the negative x squared minus 2x divided by x squared minus 4x plus 4. Number 8. It says prove that limit as x tends to 0 of absolute value of x divided by x does not exist. Find limit as h tends to 0, 2 plus h raised to the power 3 minus 8 divided by h. It says if the limit as x tends to a of f of x is not the same as f at a, what can you say about continuity of f at the point A? So as it states the types of discontinuity a function can have. At a given point, say C in the domain of f. So if our function is f, so what type of discontinuity can that function have at the point C, a member of the domain? Alright. This one says give example of each type of discontinuity mentioned, and then this one says where is the greatest in where what point, better still, at what points or points is the greatest integer function? discontinuous. So try to tell us what points or point if it's just 1 where the greatest integer function is discontinuous. Okay.